Congratulations, you've reached the first major milestone of this course. Thus far, we've built an app that can extract nearly everything there is to know about the screen on a phone, tablet, desktop, and foldable device. Now, let's dive into the principles of how to build an interface which can adapt to these kinds of modalities. If this is your first time here, welcome to my channel. Every week, I give you seasoned advice on how to build professional Android apps in bite-sized chunks. Now, let's start designing our app. Before we can start building our interface and code, let's take the time to design how this application should behave on each device type. In particular, I'm establishing the look and behavior of our adaptive interface on phones and small tablets, large tablets and desktops, and foldable devices in the book and tabletop postures. If you recall back to the first video in this course, we had a master detail view. The master view was a list of numbers from 1 to 50, and the detail view would reflect which number was selected when the user pressed on different row items. This could be thought of as mimicking the behaviors of a very simple email or messaging client. Let's dive into some specifics so that we can see how I intend our app to work. First, let's look at flat screen devices only. For compact and medium window size class devices, which would include devices like phones, small tablets, and many phablets, I would like our app to show a full screen master view. That is, the view with the list of numbers. Tapping on any one of those numbers should take the user to the detail view and would show the number the user selected. Of course, pressing the back button from the detail view will land the user back on the master view. For expanded devices like large tablets and desktops, the interface would change slightly. The master view would show on the left 1/3 of the screen, while the detail view would consume the other 2/3 of the screen. The behavior would be the same as in the previous scenario with two minor differences. If the user has just landed on the screen and has not selected a number from the list, the detail view should show some kind of default text value, prompting the user to select a number. Once a number has been selected, the details would be updated to display that value. The other change is a modification to the back button behavior. Regardless of whether the user has selected a number, pressing the back button should always exit the master detail view and take them back to the application's home screen. For foldable devices in the book mode posture, this view would behave the exact same as it would on expanded devices, with one minor change. Instead of dividing the interface into 1/3 and 2/3 for the list and detail view, this interface mode would divide itself based on the hinge location. The list will always be to the left of the hinge and the details will be to the right. This will likely look just fine on most devices in full screen mode, but if the user has put your app in a floating window, you may experience some awkward positioning of the hinge in terms of how it divides your app. In your app, you may wish to set some boundaries around how large or small of a hinge separation ratio you are willing to work with before switching your view to a more suitable arrangement. For this app, I'm not going to go into that level of detail, but it's certainly something to keep in mind. Finally, for foldable devices in the tabletop mode posture, I will be building the app just like in book mode, except the list and detail views will be stacked from top to bottom. The great thing about this process is that it affords you a high level of freedom. There's no right or wrong way to build this kind of interface because the needs of your app may vary from another one who decided to implement these details differently. My app is just one of many ways that you could have done this. I chose this design because it highlights and displays the many opportunities that you have as a developer when building your app. Next, let's move on to building these interfaces. First, we need to pass the Screen Classifier to the Adaptive Layouts route. Once the route has the necessary information, I'm going to use it to map a generic descriptor of our device type and posture to a specific description of how it should behave for this screen. I'll do that like this. I'll create an enum inside of the Adaptive Layouts route file called Adaptive Layouts Screen Type to describe how to lay out the interface. I will have one value for each scenario. I'll have list only for compact and medium devices to show just the list. Next, I'll have detail only for those same devices to show just a detail view. Next, I'll have list 1/3 and detail 2/3 for large tablets to show the list and detail side by side. Next, I'll have list half and detail half for foldable devices in book mode to show the list and detail side by side. Finally, I'll have list detail stacked for foldable devices in tabletop mode to stack the list and detail composables on top of each other. Notice how I strayed from using terms like phone, tablet, and foldable. I'm describing how this interface should be laid out, not the hardware profile. Next, I'll map the screen classifier to one of these states. I'll create a private extension on the screen classifier interface for this job. It will require a boolean to indicate when a row is selected. This information is key for the compact and medium devices to jump from the list to the detail view. I'll hardcode those values in for now. In a later video, we'll handle how to get this information. This function will return an adaptive layout screen type enum. For the first scenario, I'll check if this device is fully open and has an expanded width. If so, this will be mapped to the list 1/3 and detail 2/3 type. Next, if this is fully opened and a row is not selected, then return the list only type. Notice that since I already handled tablets and desktops for the first scenario, now I know that I'm working with smaller devices which will only either show the list or detail at any given time, but not both. Similarly, for the next case, if this is fully opened and a row is selected, then return the detail only type. Next, if we're in book mode, I'll return list half and detail half. After that, if we're in the tabletop mode, I'll return list detail stacked. Finally, for the catch-all scenario, I'll return list only. This last scenario is only to keep the compiler from warning us against non-exhaustive scenarios. It's actually not possible for us to hit this case since all of the above conditions satisfy all of the possible combinations. Now, let's map these types to composables that we'll create in a few minutes. Back in the adaptive layouts route function, I'll clear out the reference to the existing screen. Next, I'll create a variable called adaptive layout screen type that will remember savable a default state of list only. This state will quickly get replaced, so don't worry if it doesn't match the actual initial state of the device. Then I'll update the state with the value determined by my mapper, and I'll supply a value of false for the parameter. We'll take care of this in a later video. Finally, I'll create a switch statement that will provide the correct composable for each of these states. I don't have these composables built just yet, so I'll simply provide a stub value for each of these cases. Notice how this approach doesn't use the navigation graph. I used the graph to get me from the home screen to the screen information route, and also from the home screen to the adaptive layouts route, but once I have a more complex view to build, it's up to me to make it work. The graph is only responsible for bringing me to a particular route. For the context of my app, you could think of it as bringing me to a particular feature, and once I'm there, I'm on my own. Okay, let's go through a checklist of what we already have at our disposal. For the list-only scenario, I have the adaptive layouts list screen, so I don't have to build that layout. Also, for the detail-only scenario, I have the adaptive layouts detail screen. I also don't need to build that interface. However, the other cases don't have any matching composables to make them work, so I'll have to build these layouts. I'll start with the one for large tablets and desktops. I'll create a new composable called Adaptive Layouts List 1/3 and Detail 2/3. All I need to do is use a row to place the list and details side by side. Since I want my list to take up 1/3 of the screen on the left, I'll surround it with a box and use the modifier of fill max width with the value of 0.33. The details will get the same treatment, except the fill max width function won't get any value so that it can stretch to fill the remaining empty space. And that wasn't too bad. Let's build our next layout for foldables in book mode. I'll create another composable called Adaptive Layouts List Half and Detail Half. This function will need a screen classifier. so that I can get access to the hinge data. This parameter will be of type screenClassifier.halfOpen.bookMode, since this layout only deals with book mode. I'll use a row and surrounding boxes once again to lay out my list and details composables. The fill-max width modifier for the list will use the hinge separation ratio to properly divide itself with respect to the hinge. Just like last time, the details will fill the remaining width. Last, I'll create one more composable called Adaptive Layout Stacked for foldables in tabletop mode. The only differences from the last layout is that the parameter type is screenClassifier.halfOpen.tabletop mode. I'll be stacking these with a column instead of a row, and I'll use the fill-max height modifiers instead of fill-max width. Now, let's put all this together and build our adaptive interface. Back in the adaptive layouts route, I'll start to populate the switch statement cases. List only will use the adaptive layouts list screen. Detail only gets the adaptive layouts detail screen. List 1/3 and details 2/3 will have, not surprisingly, adaptive layouts list 1/3 and detail 2/3. I'll have to do one minor check for the last two scenarios since I'm passing in the screen classifier. For list half and detail half, I'll do a check to ensure that the screen classifier is of type screenClassifier.halfOpen.bookMode before passing it to the adaptive layouts list half and detail half composable. This is another one of those checks to make sure the compiler is happy. We've set up this scenario to only ever run when the device is in book mode, but our compiler doesn't know that. Last, for the list detail stacked, I'll do a similar check for tabletop mode and pass it into the adaptive layout stacked composable. Without much effort, we've begun to transform this part of our app. Let's see what it looks like on some emulators, starting with a non-foldable phone. As you can see, I can only get to the list view right now. I don't yet have the plumbing in place to react to taps on the list items. On a large tablet, I have the list and details side by side. Once again, tapping the list item doesn't do anything, but we're certainly taking a step in the right direction. On a foldable device that is open flat, I can see a similar layout to that of a basic phone. However, as I start to fold the device shut into book mode, the details appear on the right, just like it does on a tablet. Finally, on a foldable device in tabletop mode, I can see the list and details stacked on top of each other. We're definitely making our way into the home stretch. It feels like we've made so much progress in just one video, and that's because we can finally start to see the results of our work. There's a bit more plumbing we're going to need to do to make this function as we would expect. View models are going to be key to get these separate composables talking as one cohesive unit. We're going to take care of those final details in the next video.